Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Today we have Jonas Bonér, who is the CEO of Lightbend and longtime good friend of mine who I got to work with for about a year and a half, which was amazing and I loved it. So it's really fun to have Jonas joining us. He's also the creator of Akka, which is amazing technology that we'll dive into. But welcome, Jonas.
Thanks a lot. I'm happy to be here, and really good to see some friendly faces again.
Yeah, that is a really nice thing. It is good to see your face. I think the last time I saw you was, I think at the Java Zone in Oslo or something like that a couple of years ago. Maybe that was.
I actually think it was J-Focus. I thought so.
Oh, that's right.
Yeah,
Yep.
we went out to dinner there. I think
that's right. We went out to dinner there. That was
with Ryan and some other people. Yeah, and it was.
Yep.
When was that? It was
wonderful.
3 years ago or something. It was,
I know. I missed those days. Hopefully, we get back to that soon.
So I have a question because you are a technical person.
Despite the CEO title.
Heavily. Well, that's the question. And it's like you see this happen where somebody who has this strong technical background is elevated to CEO, which isn't really a technical position, but what are the benefits and downsides of that kind of promotion? Because it seems like you can make decisions with that strong technical background, but now you're kind of isolated in the C-level and you don't get to program, which is arguably your strong suit.
True. I mean, I think no one's really born CEO. I think everyone grows into it, regardless of which function they have. And I think in technical companies, it's not that unusual to have a technical CEO. And I'm not saying that it doesn't work to have a business-oriented CEO, but I think it can actually work quite well in technical companies because it's about the product and understanding the vision and where the company needs to go in the market. It's harder for a business level CEO to understand how to first understand the technical market, where to take the company strategically, but also how to position it well among others and among competition, and to how to talk to investors and the board and partners and customers, which
in some ways your customers are developers, and
exactly.
So you can talk to developers because you are a developer and you understand developers, which definitely one of the challenges that I think that a lot of businesses have that are targeting developers, who the management and marketing and all those other functions, they're not developers. And don't really
and plus there's a trust factor. It's like if somebody who's a business person comes along and says, you developers trust me,
right?
You will like this product. And it's like, no, I don't trust them because they don't know anything about this. Whereas if you come from that technical background, it's like, oh, I know what you've done and you know what you're talking about.
Exactly. I feel that's a really strong point. And there's some credibility in coming into companies, talking to technical people. And when it comes to the other areas, I simply need help. I in 10, 15 years, if I continue doing this, I might not need as much help. But now I can honestly say I need a lot of help on the business side and also on the operation side, which is like why I'm really happy to now work with a great COO that helps me running that part of the business. So which are having really good, Sushila.
Oh, she is just
who you know, James. I know.
Yeah.
I think we complement each other well. I can focus on the technical strategy, the bigger picture, talking to customers and, as I said, partners and stuff, and leading the teams and around that rally support around where we're going, and she can help with the with the more business oriented things. So,
and the few times that I met her, I feel like she would probably be pretty easy to work with too.
I mean, we work really, really well together. We worked together for 10 years, so we know where each other's strengths and weaknesses,
I want to hear a little bit about the history of Lightbend. I know some of it from my time there, but just run us through how it all started and the transitions that you've made and products and some of that.
Sure. Yeah. So it's, I need to go back a long time. It started out. I was doing consultancy for myself. I'd worked at companies like BA Systems and the JRocket team. I worked at Terracotta, tried to do distributed computing, in a very seamless way. And then after all of that, my strong area was sort of concurrent systems, distributed systems, and I was doing a lot of consultancy here in Sweden, different companies around that, and I got sort of a little bit let down, I would say, or a little frustrated by sort of state of the art of platforms and libraries and tools how to do this. That said, the context is that I was mostly working, or actually exclusively working on the JVM, and there's a lot of good stuff in the JVM, absolutely. But when it came to distributed systems, you had Corba, and then you had EJBs, and then you have an RPC libraries, and it was all okay, but it wasn't really. It didn't really pull it together in a simple fashion, and I started tinkering with other things, like I came back to a language that I really liked in school, Erlang, and
Of course, because you did school in Sweden, you were taught Erlang.
Yeah, exactly. So it's,
because of Siemens. Is it
yeah,
Siemens?
And back then, I sort of hated it. I was immature. I thought the syntax was really clunky and stuff. But I sort of rediscover that, and most importantly, rediscover the actor model. It felt like this is really too good to be true. It's like the perfect model for building distributed systems. It's the most honest way of abstracting over distributed systems, to really bring in all the challenges and making them first class instead of trying to hide them. That was the big revelation for me. That is, most other tools, in DGBs, distributed objects, all these things, Corba, they all try to abstract by hiding complexity, and then hiding, the truth in a way. I mean, actually, the nature of
the things can fail, and messages cannot reach their destination, and
that seems like a really important part of understanding abstraction, because you are trying to hide complexity with abstraction to make things simpler. But then if you hide the wrong thing, then it makes it worse.
Exactly.
Yeah, because EJB, there wasn't really a error model for this message may not be received, right? It's like
exactly.
So they hid the wrong things.
That is the problem. It's if you abstract the wrong things, you actually, for the happy case, it's beauty. It's just for Hello World and all things, a presentation type of code. It looks like amazing, because there's no everything's abstracted, but it's abstracted away.
It's
but
like, look, you don't have to think about that this thing may possibly fail. When it's like, but if I do need to think about that it might fail, then what is it going to look like? What's my programming model going to look like? And
exactly.
Yeah.
And in that case, it's actually better to have those things exposed. And I think the most honest way of doing it is like the actor model does, with this fully autonomous components, that communicate over messaging. And messaging is async, and messages can not be delivered. They can fail, they can be dropped. So you have that built into the model. But instead, then it sounds like a downside. But the good thing is that it adds on top of that a really good failure model, how to actually deal with those situations. So it's really all under your fingers and all easily understood, and can make it easier to build reliable systems, really. And I also have to say, the thing that I loved most was, of course, first the failure model, but also that it's actually treated concurrency as an optimization. That, and what I mean by that was that distribution was first class. So you had one model for communicating, regardless if you were running in process, running on multiple cores, running on multiple nodes, running on multiple data centers. So regardless if you're in the same machine doing distributed computing across cores, which is really distributed systems, it's just that we don't see it.
Just lower latency distributed.
Or you do it on a global scale. It's the same programming model.
Yeah.
While if you use other tools, like you have to like use like threads or locks for doing concurrent programming. Then you need to perhaps use RPC or I don't know, whatever it is, multicast or whatever on a bigger scale. It's like different tools for different layers in this ladder of distribution.
Whereas in the actor world, it's like the actor model is the one way to do all essentially distributed or multi-core whatever computing.
So could you possibly say that the actor model is a generalization of communicating sequential processes?
It's a sister or a brother. You can say. The way I view it is that they're very similar. The different sort of ways of the different views about the same problem, but they are sort of exposed to the program differently. I like both, but what I like about actors is the thing that it makes distribution the thing, and local communication is just a result of making sort of picking the most general abstraction for the job. It just works, While CSP is mostly, it doesn't have distribution built in that sense,
right?
Right. The key thing here, why it does that, is that you actually have these autonomous addressable components, and since they're addressable, they can run anywhere. So for if I send a message to you, I'm just sending it to your address. An address is this abstraction, and wherever you might run, wherever that address might point right now, I don't have to care about, and that means that you can actually move around. I mean, you can fly over to Seattle or wherever, just talking to this address, and the message gets relayed to where you happen to be, which is really beautiful and makes it very, very easy to conceptualize systems.
I find that whatever concurrency mechanism, because there's a bunch of them, whatever you look at, it always seems to have strengths and then weaknesses or limitations. So what would you say the actor model's limitations are?
The actor model limitations, it's composability, I would say. That's the main thing that comes up, that people, especially people coming, only people coming from functional programming, that's been sort of understand.
People coming from they don't care because they don't have composability anyways.
Exactly. I mean, they think it's business as usual. You simply can't put two objects together anyway.
Right.
You have to do delegation and all these things.
Right.
But it's. But for people coming from functional programming that used to work with functions, it's really clumsy.
It's not a direct model for taking two actors and creating a new actor that combines those two actors.
Because the whole point of the actor is that it's completely independent.
Yeah, exactly.
Yeah.
Exactly. And another thing also that many actor implementations lack, that we actually added to Akka, just a few years back, and didn't have from the beginning, is types. That you only have a type any, or whatever you want to call it, depending on the language. The top type, because an actor can take any message, but it doesn't necessarily have to do that. Actually, since the actor can actually be seen as just a function, sort of a behavior that can actually have a type, that can only accept messages of a certain type hierarchy. So that's something that we added in Akka, in what is called Akka typed.
I have not used the Akka type stuff yet, and I really need to, because it'd be interesting for me to experience that. Wasn't there one of the kind of fundamental issues with doing type to actor stuff was that an actor can become a different type or something like that, and that kind of made the model of typed actors challenging?
Yeah, it's really one of the most powerful things, that an actor can sort of redefine its behavior for the next message. It can accept a message like Okay, let me like explain it better. It's really the way I see it is really, it's really like a state machine. So it can move depending on which message comes in. It has the option to move to different state, and in the state machine, and by doing so, it can choose to accept a different set of messages. So that means that if a late arrival of a message comes in, and now you redefine the behavior of the actor. For example, you might have a component that has an init state. You can only take like start, and then it sort of redefines the behavior to become started, and then you can do a bunch of stuff, regular business logic, and you might have stopped, and then if you send a stop message, it gets into stopped, and then there might be end of it, or you might be able to restart it by accepting a start message. But but that means
you
that there
can't
are
convey that like
invalid.
runtime semantics of what the allowed messages are at runtime, because it's changing at runtime. You can't convey that in a static type
Exactly.
system.
Yeah, it's very dynamic.
It's hard. There is some research being done here, in this area using session types, but it's really nothing that I have dig deep into. I know some people in the Akka community have, like Roland Kuhn and others. So we don't have them, but there are ways of doing that. So contextualized typing in a way, but it's. But I think just having types and having types in this redefined behavior, because Akka type still allows you to redefine the behavior, but you have that in a typed way, and that means that you can do a lot of interesting things anyway. So, but it's not the full power of everything you can do with types. That some functional programming geeks love. So it is a compromise still, and that's why a lot of people love more pure functional programming, and then with some added concurrency to it.
It feels a lot well, I'm kind of slowly developing a model of what Smalltalk was about, but this seems like it has a lot of that stuff, because the LNK eventually came out and said, well, it's actually about sending messages and not about the whole object thing. But still, the way I see Smalltalk is that the emphasis was on, we want to build systems fast. So if you have an object that does some things, we'll build on top of that, and then you can send any message to any object, and it will tell you at runtime whether it can accept that message. It sounds very similar to this.
Yeah, in a way, it's possible to like duck typing in a way. But it's not the way I would recommend things. I would I always tell people that you should think about actors, doing one thing and one thing well. Then you have specific hierarchy of messages, and have ideally use types if you can, and that will then you won't run into any problems really. So.
Yeah.
So anyway, we didn't. I don't think I connected the dots, So I found Erlang, and I ended up with creating Akka, which we've already talked about.
And when you created Akka, it was just Java, right?
Sorry.
When you created Akka, it was just for Java.
Yeah. No. Exactly. It was implemented using Scala, because I used Scala, for quite a few years back then. Already started using it in 2005, I think, something quite early, and or reasonably early, and I started Akka in 2009, where I shipped the first release in 2009. So Akka is built in Scala. It was like the perfect language from the JVM to build these type of things. But all my clients use Java, So most people don't realize that Akka first had a Java API, and then I felt like, of course, I need a Scala API, and started adding that. And then it grew out of the Scala community to more of a, being embraced more heavily there. But in Lightbend, honestly, today we have a majority Java developers still. It's about probably 60-40 or something from Java versus Scala.
In terms of customers?
Yeah, in terms of customers.
Yeah. So you created Akka, and you were doing consulting around it, but then at some point there was a merge or something with Martin and the company behind Scala. So run us through how that all transpired.
Sure. It was actually funny. I was speaking about Akka at a I think it was QCon in London, and Martin came up and said, "Hey, do you want to go and grab a coffee?" And of course I was little bit starstruck there. I knew him. He was like this world class, famous language designer. So
Yeah.
it was fun to. He was really humble and open, and he with we immediately felt that there's something here. He wanted to. He had a really strong urge also to not just build the best language, but build one for this new emerging language that's really great for this new emerging set of applications that we're starting to see. And when multi-node and multi-core were really a thing. It was really before people started calling it cloud, but it was clear that distributed systems and being the need to write effective and correct, even more important, concurrent systems was important. So that's why he felt that Akka could be a great fit. So we joined forces there, and then we took some investment and formed TypeSafe at the time in 2011.
And one of the companies was called Scalable Solutions.
That was mine. Yeah.
Okay, that was yours.
Yeah.
And then did Martin have a company that behind Scala? Did he have a company?
Yeah, he had a company called Scala Solutions. So it was
Scala Solutions. That's right. So Scala Solutions and Scalable Solutions merged into TypeSafe.
Into TypeSafe,
yeah. That's awesome.
Yeah. So that was fun. That was fun days. It feels like a long time ago.
One of the other things about Akka was, I think, I want to say back pressure.
Reactive.
The reactive
manifesto.
Yeah.
Right.
Yeah.
And I haven't completely integrated that. It was like, how would you describe the problem that you're solving there?
Run us down the 4 traits of the reactive manifesto.
Or it doesn't have to be that. Maybe your own perspective.
When I was at TypeSafe was when we came up with the reactive manifesto.
Yeah. James helped me a lot with that as well. It's first I need to say there's 2 things. We started, the reactive manifesto is something we started to try to educate people how to build this new class of application that could be concurrent or distributed, sort of bring these things together. A lot of, we learned a lot from Erlang and Pat Hell and the tandem systems and, standing on the shoulders of giant there, but trying to just conceptualize it in a very simple framework, you might say, how you could think about these new type of systems. And that had message passing is a fundamental underlying primitive that enabled resilience, elasticity, and responsiveness. You should go to reactivemanifesto.org if I'm telling the audience. I'm sure you guys have seen it.
Signed it.
But anyway, so that was a way to try to create a common vocabulary, how to talk about these systems, because it was clear when I was out there talking with different communities, they all wanted the same, but they had different ways of talking about it and different ways of looking at it. So I felt like having some sort of common ground here would be important, and also just sort of call for arms. We're on this together. We need to understand how to build for this new emerging cloud, and what is the best way from a programming model perspective, only when you design applications and things like that. But I just want to
back when the reactive manifesto was written, the word reactive was not super commonly used.
Yeah.
And it's been really interesting to see now, if you watch Josh Long talk about Spring Boot, it's reactive. And so the world has really made this huge transition towards reactive over the last 6-ish years or so, and it's been cool to see Lightbend's and TypeSafe at the time's impact on that direction and really making reactive an important thing.
But let me see if I can, because what has been forming in my mind is that the essence of reactive is a way to make sure that things don't overflow.
Yeah, but So this is a common misunderstanding, it's not. I would say misunderstanding. It's a confusion of terms, rather. So I want to. So if I should try to explain what we try to do with Reactive Manifesto, and with the reactive systems, as we talked about, is a way to look at systems programming more holistically. Distributed systems, multi different parties can be connecting systems more the bigger type of the design, but something that also worked. As we talked about, if you use the right abstractions, they also work in the smaller types of designs. All the way from concurrency all the way to globally distributed systems. What are the patterns and the practices that can bring all this together? At the same time, there was a sort of a trend coming coming out of functional reactive programming, that was FRP. That had a really strong focus on flow control, and that led us to create sort of the reactive streams specification. So it's called reactive streams.
Yes, I think there's like two umbrellas. There's the reactive systems umbrella, and then there's the reactive streams umbrella. And They have a lot of common traits across those.
Yeah, I mean, one is a subset of the other. Reactive streams is a great tool to build reactive systems. So there's not like either or wrong or right or us and them, or like it's just one tool out of many reactive tools trying to build reactive systems, if that makes sense. So reactive streams was extremely successful. It was originally, I think it was Victor Klang that actually started it, and he did a lot of work in pulling together great people from many different companies. Oracle, we have Doug Leah there, from university. We have Netflix, we had Facebook, we had
there was anyone doing like
Pivotal. Yeah, we had all the important companies
anyone doing streaming stuff was involved in the reactive
about
streams.
2 years to create this really simple specification on how you should do flow control in a standardized way, which meant that if you built a library that had anything to do with streaming and you implemented that reactive stream specification, you could be guaranteed that it could be composed with other libraries created by other vendors, and sometimes even actually other languages, because people have ported this over to other languages, and they will just compose nicely. So you wouldn't get things starting to break when you had things cross systems or across libraries. But
let me see if I can. I always try and go for the core simple. So it seems like, all right, if I want to create a system where some component says, okay, I'm getting too much stuff right now, it needs to be able to talk to whoever is giving it the stuff, and that thing needs to be able to say, oh, okay, I'll slow down, or something like that. So every component in the system has to be able to have that, I don't know, interface signaling mechanism, and respond to it. Otherwise, if one component doesn't, then the whole system doesn't work.
Exactly, and the opposite. I have nothing to do here. Feed me more stuff. It's like this constant handshaking and negotiation of the rates. You can say, give me more, or please slow down. And I think that's key in order to build resilient systems, that you can actually get this sort of steady state, which sometimes can vary, depending on how many resources you currently have available, how many users are currently, hitting you, etc. So,
okay, yeah. Okay, so that was Reactive Manifesto, Reactive Streams, which were huge innovations. And I think one of the themes that I think about with Lightbend is that you all have led the way in so many different charters, initially with functional programming in Scala and distributed systems with Akka, and then with all the reactive stuff. And now as a company, you're moving on to, I think, the next innovative phase, which is around Akka serverless. So run us down on Akka serverless and what this next innovation that in 6 years it's just going to be normal and everybody's going to be doing it. But you're there today. So what is it?
Okay. Sure. So we pulled together this platform around Akka, still Akka. No serverless. I just want to explain how we got to where we are. And for the last 10 years, a lot of customers have used that. Mainly large customers that has the need for rock solid availability, systems that can never stop, never fail, or never have any downtime. They always fail, but they shouldn't be down for that, just because of that. And really a lot of scale and things like so. That's what sort of attracted people to Akka. That said, some criticism of to ourselves is that it can be sometimes a little bit hard to build systems using the actor model because it's so honest and it's so true to the complexity. So I wouldn't say, you can argue about this, of course, but in my opinion, it's not really. It's actually essential complexity. It's not accidental complexity. It's like needed complexity because it's the complexity of the world that we are trying to build systems for. Distributed systems is hard. That's why it's hard to build distributed systems. It's like it's simple as that.
That's a tautology, I think.
But it can still be sometimes overwhelming, especially if you also have to pull in the infrastructure and manage all the infrastructure and how things work there. Even though Kubernetes has done an amazing job here, it's still hard to pull all of these pieces together and build systems for this. And the biggest problem is what most people love about Akka is that it gives you all the options in the world. You can do anything with it, and you can do it in any way you want. So there's too many choices, too many decisions, and if you know exactly what you want, that's a gold mine. You can get exactly as much for performance as you want. You know exactly where the trade-offs are, what you're sacrificing to get what you want, etc. But if you don't want to do that or don't want to learn that, or just you might know it but don't want to be slowed down by these decisions, then Akka serverless is really the next step towards that because it really makes the most out of the cloud.
Creating a more constrained
into the cloud. Sorry.
It's creating a more constrained world so that it's easier to learn, easier to build things for specific use cases on. And
Exactly.
I guess we didn't talk a whole lot about Akka streams, which is, I think, another one of these where you've taken the Akka foundation with Akka streams and you've built this stream processing framework on top of it. So it's a more constrained world, but still built on top of that foundation of Akka. And I love Akka streams. I use it on a number of projects. And so anyways, back to Akka serverless. So you've done this thing where you've constrained the world.
Streams, or if I should say anything about Akka streams, is that what it did was adding streaming in a typed way. And I like that you actually pull it in here because it was our first attempt in abstracting over the actor model. Because Akka streams is just actors pulled together in a fully type-safe way with flow control between them. So it's really like a DSL for doing streaming that makes most out of the actors. All the failure management, all the distribution, everything that we love about actors. But you never see that. You just see this DSL because we try to do the best. Get the best tool for that specific problem. And in a way, Akka serverless is a little bit like that. First is, of course, serverless. And what does that mean? That means it runs in the cloud. It's pay as you go. You subscribe to it. You just upload your code in a way, and you never see the servers. So and you just pay for as much usage as you want. And everyone loves that, of course. Well, not everyone. Some people want to get probably squeeze the most out of the system. They perhaps rather do it themselves. But most people feel like that's like a relief. So Akka serverless is really a programming model that in that realm, so to speak, in that experience that you don't have to see the servers, you don't have to think about any ops really. It's all on us. But what it really does is exactly as you said. It takes all this great stuff we've done the last 10 years on Akka in building these amazingly scalable systems with millions of actors concurrently, literally millions, and scale to whatever, and with rock solid availability, and it reduces the options, it reduces the decisions. So it's not a tool for everyone. You would not create, I guess, like high frequency trading type of application on this. Of course not, but most systems, I think it is very suitable for the things that you would naturally run in the cloud anyway. So and it does that by I don't know if you want to talk about how it does it, but
let's talk about the domain problem that it primarily is targeted at around state and database lists, or I think you call it database lists. But let's talk a little bit about that, and then we could talk a little about the underlying stuff too.
Yeah, sure. So It is a contract first or API first approach, where you start out by defining your public API. I mean, how should you interface with the outside world? What commands and events, and requests, responses, if you want to talk about it like that, should you respond to? And essentially, sort of three things that you define in this sort of schema, you might say. That's now in protobuf, but we might add others. We talked about adding an open API later, and might be other formats you can do this. But it's really declaratively defined how you communicate with the outside world and how you communicate internally through eventing, and also the most important thing, what your domain state looks like. What does essentially your domain model and how you think about domain state. So you model that declaratively in this schema, so to speak. And then thirdly, you define, what kind of, how it's semantics essentially. How should you work with this state? And through that we provide different what we call state models, because we believe that it's not really one size fits all when it comes to state. State is really at the heart of distributed systems. It's the hardest thing. Why a lot of products ignore it, including current serverless. Current serverless is stateless. They're sort of pushing the problem of state.
Make state somebody else's problem.
Yeah, makes it someone else's problem. Exactly.
Yeah, but in Akka serverless, you said no. State is the problem that we need to deal with.
Yeah,
state is the hard thing, and can we create a programming model that makes distributed state first class, easy, and something that is not. You can just punt on this problem, which I think most people do, or you can use something like Spanner. To deal with distributed state, and there's a couple other options out there. Fauna, right, is another one.
Yeah.
But so going further to the state models that Akka serverless has.
Yeah. So I think different types of state has ideally, I'd say, different type of needs. It has different guarantees in terms of how consistent it needs to be, how available it needs to be, how if it needs to be durable, or if it's fine with being replicated in memory. All of these things, essentially, boiling down to throughput, latency, performance, and consistency, in correctness. So all these are trade-offs. And if you only have one way of solving and then pushing it down to a SQL database, then you have the strongest guarantees, but you have to pay that price for all your state, regardless if you need it or not. So we were thinking, okay, instead we should provide you with state models that sometimes give you that strong consistency if you need it, but also other options that doesn't have that, but have more headroom for scale, and that can be made more available. Because if you have a single database, even if it's replicated, it can still be a single point of failure because the network might go down and it's not available right now, or it might bottleneck because it's just too much data that has to be go in and out of it constantly. So it's not always good to have just one tool for the job. So we have now currently 3 different state models, but I'm sure we'll add more later. But the idea is to give you state a la carte, or consistency a la carte in a way, to choose the best tool for the job. But I think the biggest innovation that we have is that we're not, as you alluded to, we're not just serverless, but we also completely abstract storage. We abstract the database, and we talked a little bit about it. What we call it is some corny name, probably databaseless. I don't know, but it tries to paint the picture of that it's like serverless, but it's the next step. Serverless
and stateless, or serverless and stateful,
and a database in a way today. So you still see the database, and you have to interact with the database through APIs. But in Akka serverless, it's all declaratively configured, and we just deal with it for you. Replicate it for you, store it for you, making sure that it's always available, always in process when you need it. You never have to go and fetch it. It's always just there. It's like persisted in memory in a way.
So it sounds kind of like, well, I keep thinking of Python has this concept of generators, and basically it's a function, and then when you call yield, it stops the function, it produces a result, and then you can restart the function later, and the state of that function is maintained. But where would you store that kind of state when you're dealing with the serverless system? Like, do you just...
I mean, it's similar, absolutely. So you can just and you can literally do that. You can suspend a component, in process, and then resume it, and its state will just be there, and it will just continue. And during this process, it might actually have been relocated somewhere else, because that's how we adaptively have tried to optimize things. So it doesn't need to run on the same node even. And you ask about how that. That my answer is that depends. It depends on the state model. For example, we have what we call replicated entities, in which means that it's just in memory state replicated to whatever number of nodes you want. So it
never
can be
written
as
out
available as
to
nodes
durable
you have
storage.
available, but it's not durable. Sorry.
Yeah.
But
if it's never written out in that case to durable storage,
Exactly.
it just exists
And
in memory, but it's distributed across many nodes. So as long as all your nodes don't go down, you're okay.
Exactly. So and
It's
that's
just one state model.
For that. By the way, we're using conflict-free replicated data types. CRDTs, as a lot of people might know about, and that's great for things when you don't need, like things that are not your domain state, for example. Things like where you just want to do some coordination between components, where you perhaps want to do some counting between components, when you want to agree upon something. More like scratch data, like I used to talk, like to talk about it. While
derived
state,
derived state. So if you're counting the number of likes on a post or something like that, and in this model you will have the log of everyone who clicked like, and so you can derive that count, and you can then have that easily queryable.
So you could reconstruct it. If everything settled down and went away, you could go back and reconstruct it.
Exactly. But for example, for a classic domain state, the things that you will naturally put in a database, that's not what I would use. That's not the state model I would use for that. For that, I would probably personally use event sourcing, and that's another state model that we have, where you simply log all the events come in, so you can always reproduce your current state by just replaying the event log. And event sourcing has a lot of other advantages as well. Rock solid auditing, at least super easy to do replication, because just replay the log. All of these really good and easy to integration, because you have other components subscribed to your event log, your component's event log, and just get the updates as they come in, etc. Right? And the good thing is I just want to say that the big difference here is that is strongly consistent, while the replicated entities are fully eventually consistent. So you have two completely different consistency semantics between these two. Sorry.
And people have been using these different state models for, I don't know, maybe a decade at this point, like event sourcing, and I don't know if CRDTs are that old. CQRS is being kind of an extension on top of event sourcing. So people have been using these state models, but the problem with them is that it's taken rocket scientists and like really much smarter than me engineers to build these types of systems, because there wasn't a good foundational programming model to build on top of, to get these benefits that you get from event sourcing and CRDTs. And so for me, one of the most interesting things about Akka Serverless is that it makes these state models accessible to a developer like me. And that's it has a programming model, it has a developer experience around it that makes it much more accessible. And that's what's been super exciting about the Akka Serverless stuff for me.
Yeah, thanks. I appreciate to hear that. That's our intent, to try to, and we haven't said that, but what we have done, since we're based on this schema, we can actually generate code for almost any language. So we're fully polyglot. So if you happen to like Java or JavaScript or Rust or Go or .NET, or
I used Kotlin for mine, and that was cool.
Yeah, exactly. Kotlin, and so and then etc. So I mean, whatever you like, it's likely that it either is already supported, or it will be supported very soon. I just also need to explain. Some people might ask, okay, all this sounds very complicated, so why can't it just use a database? That's since I get the question a lot, I feel like I just have to like to address it. That it's if I say if you're you know if your needs are that you don't need the latency and the throughput and the performance and the uptime so a database is sufficient, then absolutely that's something that you can continue using. But
I see what you're saying.
but the beauty
there is a complexity to these state models, and a lot of people I think, all right, it's too complex. There's not enough benefit for me in this, and so I'm just going to use a database. But I think they're not actually thinking through even the requirements that they should have in the systems that they build. So, for example, at some point, anybody that's doing anything with data is going to need to do something like change data capture, some way to take the changes that are coming in and do something with them. And change data capture with databases is just it's terrible. It's a terrible way to like deal with this problem. Whereas if you have a foundation of event sourcing or CRDTs, all of a sudden you have the foundation there, and when you need change data capture, you can then just drop down to that layer instead of having to try to bolt it onto your database later. So that's one example.
Yeah.
Another one is, I think it is just a terrible disservice to users that you have to like refresh a browser to see when the data has changed on a web page or whatever it may be. It's just as sad that the only like real-time database is Firebase. Like every database, every data interaction should be real-time, and everything should be a stream that exposes that data instead of the way that we've traditionally done it, where you query, you get the results. I think every web page should be live data to the underlying data, that's the data stream that's actually changing. And when you try to build this on top of a database, a traditional database, you can't. It gets impossible. Just like with change data capture, or any change data capture or any stream processing type of scenario that you want to tag on to your stream of data, essentially. Where if your fundamental underlying model is streams, is a data stream, and whatever state model you pick around that. But if your foundational model is that, it's much easier to then build all of this stuff on top of.
Absolutely.
So that's where I'm going to disagree with you. I don't think a database is sufficient for most people. I think that we just haven't had the tools to make doing it the right way and doing it the better way available to us. And so it's easy to think that a database is sufficient, but it's really not.
Yeah, no, I totally agree. I just try to be, starting by being humble and say, there is a set of use cases where it could work. But I think you really hit it on the nail here, because I think the biggest, essentially, if you want to build real time applications where in the most simple fashion, and where data is always available and always correct and always ready. Always right where you need it, fully co-located with the processing. You never need to go and fetch it when you get a request, because it's always there. It's always available. It's always, like I said, it's really not actually really persisted in memory. Effectively, it's very different from caching, where where there can be cache misses and where you have all the cache coherency problems and things like that. With the model of event sourcing, for example, your service of record is really your in-memory state, and it happens to be a mirror of that down in the database or wherever it happens to be. That you can use when things fail, or where you need to integrate, as I said, by subscribing to it. But the actual service of record is right where you need it always. So it's like zero latency.
It just is silly that in most of our traditional models, we will requery the same data over and over and over again because we've got this like stateless middle tier. Whereas what you're saying is, no, let's just do that query essentially once and keep the query updated whenever there are changes to the underlying data, and let's keep that queried data right where you actually need it. And
Exactly.
it's a totally different model to think about for data, but I think it's so much better of a foundation. It allows us to build things that we actually need for distributed systems, for real-time systems, for all these data processing, all that stuff on top of it in so much better of a way.
Yeah, I really think so. And a lot of people talk about now the edge. What that means, like pushing out more towards the edge, and I think the cloud will eventually merge with the edge, and it will be one thing. And I really believe that this model is the future model for the edge, because it's really about having state right out there where it's needed at all times, and having the underlying runtime or platform or fabric, whatever you want to call it, just making sure that it's always there and available and ready and correct. And so I think this is super exciting when you see what's going to come right like just around the corner with things like 5G, for example, with like points of presence right in your backyard, more or less, and this and having especially if you're thinking ahead, having apps that can really start like taking advantage of all this, then you simply can't afford going all the way back to your data center somewhere down to a database there, fetch the data. It just needs to be wherever the action is, and then you need something like what we're trying to build here. That said, we're building it for the cloud now, but we're also looking a little bit at the edge and how we can play there eventually, so to speak.
Yeah. Well, and it's cool that the actor model and Akka can underpin the all of this, and so you've got the higher level of abstractions, but when you're just building for state, you don't have to think about actors and how the coordination works and how the messages flow and how air handling happens and retries and moving data around and all that kind of stuff. It's all managed for you, so it's nice to be at that higher level of abstraction for state, but that the actor model can actually underpin it.
Yeah, and the way we have sort of tried to abstract it, is by, as I said, by reducing options and by providing, a simple SDK for whatever language you want to use. We essentially do most of the things declaratively, as we talked about. Actually, even the views that we talked about, the queries that you can actually write them in SQL right in your schema, and we generate or whatever necessary things to make that sort of materialized view always up to date. But the only thing left for you to do is write your function, just like serverless today. Function meaning event in and event out, and now you have also state in and state out. All abstracted for you. So it's actually, it sounds like a lot of complex things we talk about here, but the interesting thing is that all of that is managed for you. You just essentially define your data, you define your events, and you write your function, and then that should be it.
And your function being like your business logic, like
exactly.
what you got this message, what transformation or whatever do you need to perform on this message, or how are you going to update your state?
Yeah.
So
exactly.
yeah.
So it's in a way it's very similar to actors in a way that you have these autonomous components that can run anywhere and then manage state and behavior, and then they co-locate state and behavior. It looks very different from Akka, and it looks very different from Erlang, but it's still underlying at one level down is exactly what we talked about in the beginning. It's message passing, eventing is essentially message passing, in a way. It's like it's layered on top of message passing, more or less. And it's all, have the failure model built in and all of these things. It's just that you don't have to see it necessarily.
Question on, I saw on a Twitter thread, somebody was kind of asking about how initially the Akka serverless was related to Cloud State, the kind of open source, open spec project or something like that. And they weren't sure about what the current kind of relationship between Akka serverless and Cloud State was. So can you give me some
Sure.
some
Yeah.
background on
Yeah. So Cloud State was an open source project that we started. Sort of that sort of it started like this whole thing, or all this work started with some ideas, that I wrote a little article around, and I had a talk at KubeCon about 2.5 years ago where I outlined some of these ideas, and that led us to start working on an internal project that later became an external project around just testing these ideas, and that was Cloud State. So it was sort of a test bed for a lot of these interesting ideas, and the intent back in the day was to see if it's possible to create well-defined protocols between languages, being able to abstract state in this way, etc., and being able to provide this to many languages, so being fully polyglot, and also using sort of a Kubernetes sidecar architecture. That was sort of the framework for how that project started, and we got some great contributions to that project quite early on. The community has really helped us build most of the SDKs. If not, and all of them, apart from Java and JavaScript, actually, all have been built by the community around Cloud State. It's been, I feel a bit, a little bit sad talking about it, because we have simply not had the time to put in to the Cloud State project to the level that I personally would ideally have liked to see, because the whole idea was not to build this open source project that developer had to run themselves, because that's not serverless. The serverless experience is that someone runs it for you. So there's always been the idea to take Cloud State and operationalize it and to run it as a service. And it was, it simply hasn't been that we could, invest as much in the open source project as I personally would have hoped, because the act of building this platform to run it and to actually build the product for people to consume Cloud State and the ideas around Cloud State, has
and that's been
very,
your
very
primary.
time consuming. That said, the project's not dead. I really hope that we will be able to get back to it once we launch. It goes without saying that I said it's been a lot of work building up to the beta that we have right now, and we're aiming for a GA in the fall, and we'll see what's going to happen then. If we're going to have feel like we're going to have more time with Cloud State, but our focus right now is to build the greatest service for anyone, for users, to sign up and actually making use of it without having to run the service themselves, which if they use Cloud State, they would have to do, so.
Cool. That's helpful. What else?
Do you have any thoughts on business models around open source?
That's an interesting one.
Near and dear to Jonas's heart. Been doing that for how long now? 14, 15 years?
Yeah, too long. It's been changing. I've been, as James said, I've been trying to do this for a very long time. All the way out since the JBoss days, more or less.
Yeah, that's right.
But anyway, it's like I think the model that JBoss, I think it's a good starting point. The model that JBoss started, with what they call professional open source, was of course groundbreaking back then, and many companies have tried to do the same, and that later evolved to open core model, where you have open like some commercial IP, but still an open core, really. I mean, the open source was the core of it, was freely available, and you built sort of layers on top with commercial value. and that was out of necessity because it was clear. We've gone through the same journey as well. We started as a pure consultancy, enablement, training on the open source company, but it was clear, after 3-4 years that was really, really hard to do. It was harder.
It was a model that like worked for a little while.
Spring tried to do it. I think it's really been getting harder and harder. So that's when in 2015-16 we sort of embraced this open core model where we added some commercial IP to it and things like that. And that worked for a while. It still works, but I have to say that it's getting harder and harder. And the reason is that you compete with yourself. If you have great open source, great quality, if it's rock solid, then people have started to become more and more comfortable doing self-support. And since we live we make money on subscriptions on our platform and helping companies when things go bad, more now than training and consulting that like we started with. Now it's more like a pure subscription-based business. It's been getting harder and harder because more and more companies, as I said, are becoming comfortable just saying no. We can deal with this ourselves.
We'll just file an issue on GitHub.
Yeah. And the better your software is, the worse position you are in business-wise. But
that's right. Akka is just too good, so people don't need subscriptions.
Yeah. I mean, that's what my wife say and kids say. I mean, you just add some bugs then. I mean, how can it be so hard? And it is what it is. But I think we start to see the light in the end of the tunnel, because I don't think commercial open source is dead. I just think that it's starting to reshape and reform into as a service, because I really believe that. I've said that for a long time. It might not be the best analogy, but in a way, I've said a long time that I would like us to be like Netflix in a way, providing the best service, creating and delivering value. I mean, not necessarily streaming movies, but some sort of great value. It can be in infrastructure, it can be in programming models. It doesn't have to be that either. It can be whatever value you as a company delivers to your users. That's what you monetize on, and then you can actually, sort of get the best of both worlds by, as an artifact of building that value, you can release open source and build a community around, just like Netflix did, around a lot of really groundbreaking open source projects. They really got the best of both worlds. They started to build a community around it, getting bugs fixed, getting the envelope pushed when it came to this libraries and the pro, like RX Java, for example, Hystrix, many great products. But by not being dependent on making money on that, it's not sort of trying to cannibalize on their open source community. So I think that's really the future of open source: building some great value and still, get all the benefits from open source by that we see today. Having great pool of developers to hire from, for example, having developers talk about your stuff at conferences, and getting help with building the stuff that underlying your service that sort of creates value. So
now you're, as a company, transitioning to having your cloud service be one of the primary ways that you provide value to your users and customers, and that's
exactly.
the Akka serverless, and then also Akka platform piece, so people can also do the same thing, have a kind of managed environment for just Akka, right?
Yeah, I really believe that. I don't think open core is dead. That's not what I'm saying, but it's getting harder and harder. That's why I think more and more companies are transitioning to delivering things as a service, and I think that's great for developers consuming it, because it's easier and it's less headaches, while it's actually easier to build a sustainable business.
Yeah, and I think if you look at like Confluent, and they've been on the same path as you all, and now their Confluent Cloud service is doing really well and growing a lot, and they're able to provide a lot of value through Confluent Cloud as well. So.
Exactly.
Yeah, cool. Well, Jonas, so good to see you and hear about all the amazing things that you all are working on and doing. So
Thanks a
appreciate your
lot. No,
time.
really good to see you guys. I mean, I'm losing my mind here just talking to myself.
Yeah.
It's really good to
Yeah.
see
Well,
some.
hopefully we'll get to see you in person sometime
Yeah,
soon. So
likewise. I'm really hope that we can get past this madness and really get back to business
yeah.
like we
Yeah.
used to. So anyway, it was a good first step, I think. Thanks for inviting me, and I really appreciate geeking out for a while.
Yep. All right. Hopefully you can write some code this weekend.
Yeah.
All
Hopefully.
right. Thanks, Jonas.